All right, in this video, we're going to rationalize denominators with nth roots, okay? This is using the rational exponents. I'm going to show you two different ways to do each of these problems, and I'm going to kind of let you pick whatever you think's the easiest, whatever makes the most sense to you, okay? So the first thing I'm going to do is I'm actually going to go ahead and convert this cube root of x squared into an expression with a rational exponent, okay? So I'm going to make it 1 over x to the 2/3, okay? So remember, I need my exponent to be x to the first, or x to the second, or x cubed, x to some whole number. So we've got our rational denominators, okay? I need to ask myself a question. 2/3 plus what equals a whole number, okay? And we want the smallest whole number, obviously. So 2/3 plus 1/3 would give me x to the first power in the denominator, okay? So what I'm going to multiply here by is x to the 1/3 over x to the 1/3, okay? And that's that rationalizing step that we learned in the last section, okay? So when I multiply my numerators here, I get x to the 1/3 in the numerator, and in the denominator, I get x, okay? I get, I get a whole number exponent for my denominator expression there. I'm going to go ahead and convert it back into the root here. So in the numerator, I'm going to have the cube root of x over x, okay? And that's the answer, all right? Now, you may think it's easier to just keep everything in the root form here and think about what we need to multiply by, okay? So another way to think about it, I need the cube root of x cubed, or x to the 6th, or x to the 9th, okay? To make this simplified, all right? And we want it to be the smallest as possible, so I'm going to multiply by the cube root of x to the 1st. Okay, that's the rationalizing step here, okay? When I multiply the numerators, I get 1 times the cube root of x, just like I did up here. When I multiply here, I get the cube root of x squared times the cube root of x, which is the cube root of x cubed, okay? Or the cube root of x to the 3rd, which I can simplify to x. So I get the same answer. This one was a little bit quicker, okay? But I've found in the past that a lot of students kind of prefer working with the fractions. Sometimes it's a little harder to think about it in these terms. So look at both of these and kind of figure out which one makes the most sense to you, and then kind of always use that, okay? Always convert to fractional exponents, or leave everything in the roots and just use the rationalizing step like this, okay? Pause the video here, give 12 a try. Do you want to use the fractional exponents, or do you want to leave it in root form in the rationalizing process, okay? All right, number 12. So first thing I'm going to do, we're going to go back to fractional exponents again. So this is 1 over a to the 2/7 power. Okay, remember, 1 to any power is 1, so I didn't even concern myself with, well, 1 to the 1/7. 1 to any power is 1, and any root of 1 is also going to be 1, okay? So there's no reason to waste my time dealing with the fractional exponent in the numerator, okay? So 2/7. Well, I need that to be 7/7, obviously. So that means I need another a to the 5/7 to get me there, okay? So when I rationalize here, I'm going to multiply by a to the 5/7 over a to the 5/7, and that gives me my answer of a to the 5/7 over a, or the 7th root of a to the 5th over a, okay? Now, if we just want to leave things in root form, okay, I need the 7th root of a to the 5th to kind of get me to a to the 7th underneath the radical symbol here. So I'm going to multiply by the 7th root of a to the 5th over the 7th root of a to the 5th. And then when I multiply numerator times numerator and denominator times denominator, I get the same answer, okay? So again, pick which route is best for you and kind of stick with that. It'll make it easier for you.